Hey guys, this is Muib here from the University of Greenwich, and in this video we're going to look at trigonometry, but this time we're going to look at questions that involve 3D shapes. On the board here we've got a question. It's a two-part question. The first part asks us to find out the angle between x, b and a. So if you look at our diagram, x, b and a is a triangle. It's actually a right angle triangle. So we can draw this out and work out our angle, just as we did in previous cases. So here's a triangle. We know that there's 18 centimeters here at the base between B and A, and we know there's 15 centimeters between A and X. 15 centimeters, and we're asked to find out X, B, A. So let's label that as theta. Again, we did the same thing. We're going to label our sides. So here we have our hypotenuse, our opposite, and our adjacent. So now that we've labelled a triangle, we can see that we've got our A side and our O side, which dictates that we use our TOA part of the keyword, and this represents our tan ratio, which is just tan theta equals O over A. So again, tan theta, if you plug these values in, we know that our opposite side is 15 centimeters. That's 15 over A is 18 centimeters. 18. I'm just going to rearrange this. So we get tan inverse 15 over 18. Now if we plug this into our calculator, we get 39.80 to 2 decimal places. So now we're going to move on to the second part of the question, which is slightly different in the way they word it. So let's just go through it. It's asked us to work out the angle between the line XC. X is here, C is over here. As we can see, there's no actual line that goes from X to C. That's why we're going to have to introduce an imaginary line. So if we just introduce an imaginary line that goes from X to C, we want to work out the angle that this imaginary line makes with the base ABCD. Our base is simply this little square at the bottom of the shape. So now we want to work out the angle that this line makes with our base. So if we just draw a straight line, another imaginary line that goes from C to A, we know that this line represents our flat base, and this XC is our imaginary line. It's a little difficult to see here, so I'm just going to rewrite it out here. Draw this shape again. Remember, this is our imaginary line. So if you imagine from C to X is this line here, and from C to A, which represents our base, is just this line here, and from A to X is this line here. Okay, so we can write this out as 15 over here, because we know the distance between X and A is 15. However, we don't know the length of C to A or the length of C to X. Again, I'll just demonstrate which triangle we're doing here. I'll just shade it in. Don't know how clear this will come out, but there's a triangle that we've made with imaginary lines, and we need to work out this angle here. So this angle here that we make from C to X. Again, we know this is a right angle, and now we've got one side and an angle that we're trying to find out, but we don't know C and A, the side between C and A, or the side between C and X. So what we need to do in this situation, we need to look at our diagram and see if there's any way to find out C and X or C and A. Looking at the diagram here, we see that there's another triangle that emerges at the base of the original shape. It's made from C to B, B to A, and A to C. Okay? Here we've got two sides. We've got 9 and 18. So let me draw out this little triangle here, and maybe we can do some manipulation to this, and this could help us find out what C and A is. So we've got C to B. We leave that as our base here. C and B. And we've got B to A. And we've got A to C. This is a right angle triangle. We know what C to B is. It's 9 centimeters. B to A is 18 centimeters. Now here we can use this to find C and A, and then we can use what we find for C to A here and use it on this to work out our theta. So now we've got two problems now. We need to find out C and A so that we can work out our theta. Okay? Now they've given us a triangle to work out C and A. What we're going to need to use in this case is Pythagoras' theorem. Now you must have come across this before. What this is a simple formula a squared plus b squared equals c squared. Okay, this is going to be your c. Either one of these could be your a and b. So let's label this a and this b. Okay, so now we know, using Pythagoras' theorem, we can work out c by using this formula. So let's plug our values in. A is 9 centimeters. So we're going to have 9 squared plus b is 18 centimeters. 18 squared equals c squared. 9 squared and 18 squared, if you plug that into a calculator, that gives you 405. So this means c squared must equal 405. Okay, so if we square root both sides, we get c equals square root 405, which works out to be, just check, 20.12. So we now know that angle C, which is also known as CNA, so we can write that as CA is equal to 20.12. If we rub this all out, we can use this value of CA, our side CA, and write in here. So if we go CA equals 20.12, now we can just solve our question just as we did before. Okay, so we've got, let's label this again. It's going to be a hypotenuse, opposite, and adjacent. We've got opposite and adjacent, represents our TOA function. Tan theta equals O over A, which is going to be tan theta equals, opposite is 15 over 20.12. This is the adjacent that we just worked out. I'm just going to rearrange this to make theta the subject. Tan inverse 15 over 20.12. And that gives us the answer of 36.712 decimal places.